Yeah, you can go behind that. All right, Alice, this is actually a perfect opportunity for me to kind of even do a one-on-one lecture with you because no one else is in class. Because today is a makeup class because I was sick on Wednesday. Obviously, it's not like I got much better, but I'm not that contagious as much, but I'm definitely, might still be. So, Alice, the reason why I'm saying this might be a perfect class for you is because you haven't finished Algebra 2. You're currently in my Algebra 2 class, so obviously you're not done with Algebra 2. Let me ask you this. Do you know anything about this crazy saying right here?
Isn't that like with the triangles?
It has something to do with the triangle. Awesome. So we've got a triangle like that. And this applies only to right triangles. Okay? Now, if this is angle theta down here, have you seen that symbol before?
I think so.
Okay, so are you going to freak out if I ever use that symbol again?
No.
All right, good. It's just the Greek letter T. That's it. It's like I could use, or you're Japanese, right?
Yeah.
I could use ka or something like that, right? If the Japanese came up with physics, we'd probably be using ka. The Greeks did. So we're using theta. We cool?
Yeah.
It's just a Greek letter T. Usually you call this A and B and C. I don't want to call this A, B, and C. I'm going to call this H, which stands for the hypotenuse. Right, good. One of these is going to be A and one of these is going to be O.
Adjacent is below hypotenuse and opposite.
Okay, all right, good, awesome. So I got a fast question. What if I had another problem? I called theta up here. H. What's my opposite? What's my adjacent?
Opposite's down that way.
The opposite's one on the bottom,
The
adjacent's on the
is
side.
right next to that.
Awesome, good. What you're saying to me, and this is absolutely correct, and many people screw this up, so I want to make sure you know, is that we label the sides based off of where the angle is, right? So if the angle's down here, then the opposite side is whatever's opposite of it. We cool? All right. Then I'm going to say sine of theta is equal to opposite over. So I instead of writing O, I put OPP. You got it?
Yeah.
Are you down with it? Are you down with OPP?
I'm down.
She has no idea what you're talking about.
The answer is yeah, you know me. Or just letting you know.
It was a song back in like the 90s.
All right. This is how old Mr. Dalday is. Instead of that, I mean that was my joke, but O over H. So, right? And that's the saw of the SOHCAHTOA. Cool?
Yeah.
Cosine of theta is adjacent over hypotenuse. And tangent of theta is what?
I don't know.
It's the OA. See, SOH, SOH, CAH. This is the TOA part.
Opposite over adjacent.
Opposite over adjacent. Perfect. And the mnemonic device you can use for this is SOHCAHTOA. I used to belong to a club in Berkeley. It was a math club. And our chant was SOHCAHTOA. We were that nerdy. All right. So you got it? We were like, SOHCAHTOA, SOHCAHTOA. They were like, who's domicile? It's our domicile. Because we're a bunch of nerds. But you got this, right?
Yeah.
This is what? Is this in algebra? This is in algebra 1.
Isn't that like trigonometry?
This is trigonometry for
Yeah.
sure. And then there's a bunch of crazy other formulas in trigonometry. So obviously you haven't taken trigonometry yet.
Well, my dad hired a tutor, but he taught me.
some people see this in geometry. You're going to see this in physics class like nobody's business. And I'll tell you the reason why. Okay? Here's what this thing is good for. What this thing is good for, and I explained this on my lecture on Monday. I thought it was a really good lecture, and I wish I sent you guys an email. Oh, what's going on, Kaylin? Kaylin, you were here on Monday, right? Yeah, I'm just recapping the stuff we covered on Monday to Alice, because I forgot to send an email. Did you watch the archive, Alice, from Monday?
I don't think so.
Okay, all right. Let me just talk about the Pac-Man example real quick, Kaylin, and then I think she'll be caught up, because she's a really smart person. Okay, so you ever play old school Pac-Man? Where you right? All right. Old school Pac-Man could only go, you only had 4 keys you can use. You can use right, left, up, down. That's it. His entire world existed as right, left, up, down. He couldn't start from home and go and meet on a hot date Mrs. Pac-Man over there and go diagonally, could he? He couldn't go from here to here at angle theta. What would you have to tell Mr. Pac-Man to do to go meet up with Mrs. Pac-Man?
To go right up.
You'd go right and up. And say that this was like 14 miles or something like that. Well, you would have to tell Mr. Pac-Man to go so many miles to the right, stop, turn, and go so many miles up. Does that make sense?
Yeah.
All right. And how many miles is it? Well, that's where the SOHCAHTOA comes into play. If this is theta, then this is my opposite side, this is my adjacent side. If I want to find out what the adjacent side is, I can use a trig function from SOHCAHTOA, either sine, cosine, or tangent. Which one would I use if I'm interested in the adjacent and I have the hypotenuse? And say I know the angle. The angle is 40 degrees or something like that. Cosine, good. Cosine of theta is equal to A over H. We cool? I could plug in numbers, 40 here and 14 here. But I'm not, because I never plug in numbers because I'm a punk like that. Actually, you should have been able to get used to this by now. Solve for A.
Right now.
Yeah, you just put H up here. We cool? That's algebra 1, right?
Oh,
Now you can solve for A. Now you can actually plug in the numbers. 14 times cosine of 40. Do me a favor, plug that into your calculator. Solve it using whatever calculator you think you might be using. Kaylin, you do it as well. Tell me what you get.
560.
That is absolutely wrong. Oh, I'm sorry.
Oh, wait.
Is everything recorded on the back? Is that better?
It's 5.6.
Sorry about the backwards. It's 5.6.
I know it like goes into decimal. So.
How do you know it's 5.6? See, I don't actually know the answer. I guess I should, but I'm just making this problem off the top of my head.
Well, I don't know, like, at my old school, we had, like, the sheet with, like, sine, cosine, like, tangent, with all, like,
Oh, you had the unit square or the
Yeah.
unit triangle
yeah.
thing, and you actually had to memorize them? Yeah, but 40's not on the unit triangle. Anyway, the reason why I asked you to calculate is for one simple thing. I just want to know if your calculator is in radians or degrees. And apparently, Kaylin's calculator is in radians because she's telling me that the answer is negative 9.33. Kaylin, you're trying to not unite Mr. Pac-Man with Mrs. Pac-Man because you're saying, hey, Mr. Pac-Man, if you want to get there, you should go 9 miles to the left. Kaylin doesn't like Mr. Pac-Man. She's jealous. Well, no, maybe she doesn't like Mrs. Pac-Man. So, what are you using? Are you using Google or your iPhone or whatever? I don't know how to change your iPhone into degrees. Sarah, you have an iPhone. Do you know how to do that? So I don't have an iPhone. I have the dumbest phone ever. Let's see if we can figure out how to do it on Google.
Yes.
Well,
Is it 11.7?
that sounds more like it.
Okay, I got it.
14 times cosine of 40. Yep, I see what you did. All right, so what if I put Oh, no, I got 10.72. That's my answer, 10.72. And in Google, I typed 14 times cosine of 40, and I actually put the word degrees. Because I think Google initially assumes that it's in radians. We cool? All right, so 10.72. Are we cool with that? Did you get that? Are you able to get that answer? Oh,
I got 11.71.
then you're typing something in wrong. What are you using? Are you using the calculator on the?
I was using like this one, so I was just trying to find like degree of
Try use just Google. Just type it into Google search. 14 times cosine of 40 degrees.
yeah, 10.72.
Well, let's see. On your on a regular calculator, because Kaylin's asking me, well, how are you supposed to input that on your calculator? Well, on a regular calculator, there's usually a button in the middle on the top that says mode. You click on that, and then that will switch from radians to modes. I'm describing something to you that is old school, a calculator. I know you guys use phones nowadays, but I mean, I used to use a calculator back when I used to go down to Blockbuster Videos. I would hop on my dinosaur and use my calculator because I'm old. So apparently on a calculator, that's what you would do. You would click mode and you would go to degrees or radians, and you would be able to switch back and forth. On your phone, I would just look it up to how to switch from radians to degrees, but I know there's got to be a way. Or you could go through the painful process of converting 40 degrees into radians using geometry. And I know that that's what Mr. Loving is teaching in geometry right now. And so I'm sure that you guys must have had that someplace. And then take that number and plug it into your phone. And that would be a big pain in the butt. So just learn how to switch your thing into radians or degrees, and you'll be all right. Am I being extra sarcastic today?
I don't know.
Okay. I'm just wondering. My throat is really sore. All right. So we're cool with this? Did you get 10.72? All right, cool. Can you do me a favor? Can you find O for me? You would do the similar thing to finding A. It's just you would find O instead. Cool? Do you know how to do that? What did you get for O? And I don't know if that's the right answer, but I can tell you in a ballpark figure that should be relatively close. 8.9? All right, I'll go with that.
I was just making sure I'm using the 10.72 for like the adjacent part for the that's tangent.
Oh, I see what you did. I see. You did this. You said, okay, well, tangent of theta is TOA, opposite over adjacent, right? Right? Is that what you're saying? And so you said O is A times tangent of theta. I applaud you. Very good. Don't do that, though. And I'll tell you why. That was good. That was very creative.
Was it the answer though? Or
Yeah, it's the right
okay,
answer.
okay.
It's the right answer, but I'm going to tell you why that's dangerous to do. What I would rather do is this. Sine of theta is opposite over hypotenuse. H sine theta is equal to O. Plug that into your calculator. 14 sine of 40. Tell me what you get. By the way, this is not a 0. This is O.
Times 40.
Yeah, so 14 times sine of 40 degrees.
But then it says like R and D at the ending.
It's because you're using radians.
Okay.
So 14 times sine of 40 degrees. 8.99. Cool? It's actually 8.999, so I'm just going to say it's, well, fine, I'll say 8.9. Are we cool? All right. Alice, I'm impressed that you went this route. But the reason why I'm saying don't do that is because this. In this calculation here, you used two numbers that were given to you. 14 sine of 40. So your answer is going to be correct, right? Well, in this calculation right here, even though you got the same answer, what you did was you used a number that was given to you, but you used a number that was calculated to get your answer. Here's my question. If this were like part A of a question and this were part B of a question, what if you did part A wrong? Then you're screwed. Then part B will be wrong as well.
Yeah.
But if this were like part A of a question and this were like part B of a question, then if you did part A wrong, you'll still get part B right. Does that make sense?
Yeah.
So, but I love the way you went about it. I thought that was creative, and you got to the right answer. I'm just saying, in the future, try your best to only use given numbers, and don't use numbers you calculated previously. Now, you won't always be able to do that because often problems will require two steps. And in order to move to the second step, you need the numbers from the first step. So, then you're going to have to deal with stuff like that. But as much as you can, try to stick with just using calculated or given numbers. Does that make sense? That has to do with chemistry as well. I mean, like in chemistry, you try to use the most sig figs in everything. This number has more sig figs than this number. The reason being is because you only wrote down 4 sig figs, so the best thing this thing can be is 4 sig figs. Does that make sense? Whereas these ones were just straight up 14 and 40. So that, anyway, it's a whole discussion that I'm getting to that I'm probably making any sense. All right. So apparently, Mr. Pac-Man, with 10.72 miles to the left, or maybe 10.72 miles east, right? And then 8.9 miles north. And then you get to go on your hot date with Mrs. Pac-Man. Are we cool? Now, I guess your other question for me is this. What the heck does Pac-Man have to do with real life? Right?
Yeah.
Come on, you are kind of thinking about that, yeah? All right, I'll tell you why. Here's my motivation for it all. We've mastered one-dimensional motion. What we haven't mastered is two-dimensional motion. And I'm going to tell you this. In physics, what we do when we want to deal with two-dimensional motion is we don't. All we do, Teacher's like, what the heck is he talking about? When we deal with two-dimensional motion, here's the big secret of it all. All we do is we break that two dimensions up into two separate one-dimensional motion problems. And then we apply our same old equations, those 4 equations I gave you, all the 1D motion equations. In 2 dimensions, I'm not going to give you any new equations. It's the same 4 equations. All we do is we take this two-dimensional thing and we break it up into 2 separate one-dimensional things. Does that make sense? And the way we do that, the trick that we use is this trigonometry thing. If we have a vector and we're throwing a basketball at a velocity v, then we say, well, I don't know how to solve that in 2 dimensions because the motion that it undergoes is a parabola, and that's getting closer to real physics. This is motion in 2 dimensions. We don't know how to solve these problems. So here's what we do. We take this 2-dimensional vector and we say, well, I can break that up into 2 one-dimensional vectors. I'll show you which 2. It's this one right here. Vx and Vy. You see that? And then I can do all my old physics, all the one-dimensional motion physics, but consider Vx and Vy. And so, what is Vx? In fact, I'm going to do this problem with you guys right now, and then you're going to probably do this same exact problem so many times that you're going to memorize how to do it right off the bat. I'm going to assign so many of these problems that make you do this as the first step, that you're going to memorize how to do this. And you know what the funny thing is? I bet you 1 or 2 times you're going to screw it up. So I told you how to do it, and I'm going to tell you that I'm warning you that I'm going to make you do it. Just letting you know. I'm not like laughing at you, funny, ha ha. Nor am I trying to be mean. I'm just saying that be careful with this. All right. Vx is your, okay, if this were theta, then Vx is which side? The adjacent or the opposite side? Adjacent side. And capital V is what? Capital V? The hypotenuse, right? So this is the x component of your velocity. And this is the y component of your velocity. Does that make sense?
Yeah.
So, is there a trig function I can write down that relates Vx and V and theta? Kaylin, you can jump in anytime. Cosine of theta?
Yeah.
So you're saying cosine of theta is equal to what? Vx over V. We cool? So Vx is equal to V cosine theta. We cool with that? Good. So, can I erase this, by the way? All right. So I'm just going to write Vx equals V cosine theta. What is Vy equal to? You're so lost.
I'm confused. What did you say again?
What is Vy equal to? I'll give you a chance. You can write stuff down. Practice it out. Kaylin, you can chime in anytime you want. I'm putting Alice on the spot. She doesn't like being on the spot. Come on, help her out. You're so quiet. Tell you what, I'm gonna go fill up my water bottle with water. Why don't you tell me what Vy is equal to? I'm just gonna go to the sink over here. Did you get it? Nope. Not a number. And your friend Kaylin hasn't even chimed in. No help from Kaylin. All right, I'll tell you what it is. Ready? It's V sine theta. Because sine of theta is Vy over V. Right?
Oh.
So Vy is V sine theta. What is that? No. To be perfectly honest with you, we rarely use tangent in this level of physics for now. It does sometimes appear. I'm just letting you know. So I'm not going to say that it never appears. I'm just saying, to be honest with you, with what we apply vectors and trigonometry and physics to, we don't really use tangent as much. Let's see. Do you understand this? You get this?
Yeah.
Okay. If you can get this and understand this, then this is pretty much the entire chapter 3. And I was going to spend like 2 weeks on it. I really don't feel like I need to, but I think this is good stuff. Why don't we do this? Adding and subtracting vectors. This one's a good one. This is the kind of math that... Kaylin, can you hear me? I just need a yes or no. Are you eating a sandwich? Oh, okay, you can. Ah, so she did hear all of those fibs I was making about her. Oh yeah, no, hey, it's all right, it's all right. Take care of what you need to take care of. Okay. You could see you can't see my smirk, and I don't know if my humor and sarcasm is coming across with this mask on. Maybe that's why Alice is so scared of me, because I usually joke around and I smile, but you guys can't see me smile, so then I sound all serious, and you guys are like, "Oh my gosh, she's so mean."
Yeah.
All right. Anyway, here's something that we will see when we cover forces, for sure. But it's also something that might be good for you, that you might want to look at. Let's say that I give you. Let's say that I give you a map, like a treasure map, okay? And I say, Alice, I want you to find the treasure. And here's where it is. Oh, here. I want you to find the treasure, a treasure map that I found, and so you're here, and then the treasure map is way up here. All right. Now I'm not going to know the columns or the numbers off the top of my head, but I'm just going to make up this problem off the top of my head, and hopefully it works out. All right. What if I told you, okay, Alice, what I want you to do is, you're standing here. I want you to go 30 degrees north of east for 400 miles.
Really?
Got it? That's 30 degrees. North of east for 400 miles. And then what I want you to do is go 50 degrees north of west for 300 miles. Oh, by the way, this is 400. All right, so I want you to go 50 degrees north of west, so that would be for 300 miles. Okay? Now, why did I give you such weird, why did I give you such weird, directions? And maybe because back when I made this map, I only had a motorcycle, and this is actually the road. There were roads that only go that way and only go this way and all that good stuff. But now in 2016, what up, dude? Maston, yeah, we're missing you, man. Anyway, Maston just logged on, and me and Maston are tight, so. So let me explain the problem to you, Maston. And do you understand the problem, Alice?
Yeah.
All right. All right. So here's the problem. We're going 400. All right. So there's a treasure map, and I'm starting down here, or Alice is starting down here. I said, Alice, there's a huge treasure where the X is. I'll tell you how to get to the X. You got to go 30 degrees north of east. So that would be east is this way, north is going up, so 30 degrees. You see the triangle? All right. And you got to go 400 miles. So that would be this journey right here. We cool? All right. And then what I said is, all right, now Alice, what I want you to do is orient yourself to be 50 degrees north of west. So west is this way, north 50 degrees up from west is that way. And I want you to travel for 300 miles. Okay? Now Alice is super lazy. And what she's going to do is she's not going to drive from here to here and drive from here to here. What she's going to do in 2016 is she's going to whip out her remote control helicopter pilot drone and go straight from here to there. That's what she's going to do. She's not even going to leave her house. She's going to be like, Mr. Dalday's always messing with me. So I'm straight up just going to send out my drone to go and check it out. And if there's something there, then I'm going to take my helicopter and fly it there. That's what I'm going to do. Cool? All right. Here's the thing. Here's my question for you. How far did Alice have to tell her drone to fly? And at what angle did Alice have to tell her drone to fly at? In what direction? So I need both a magnitude and a direction, meaning I really want a vector, right? And we would call that vector is this the distance or the displacement? This is the displacement, right?
Yeah.
The distance is just your length that you would travel. So if you just told me just the magnitude, that's just the distance, but you need it. If I ask you for both the magnitude and the direction, oh yeah, then that is the vector, and it's also called displacement. All right. All right. How do you solve this problem?
You got
All right, so here's what we got. We don't know how to add two vectors in two dimensions, right? But if I told you something like this, if I told you like, go 5 miles north, go 3 miles north, how many miles, what is your displacement? No.
No, eight.
8 miles, right?
Yeah.
8. You totally know how to do this. This is baby math, right?
Yeah.
If I walk 5 miles north and then I walk 3 more miles north, how far am I? 8 miles north. So we know how to do it in one dimension, right? Or if I told you something like, go 10 miles east and then go 4 miles west. How far are you from your starting point?
6 miles.
6 miles. In which direction? 6 miles east, right? Because here's you, your starting point is over here. You are 6 miles east of your starting point. Does that make sense? The reason why I had to ask for the direction is because it was a vector. If I just asked how far are you from your starting point, you would give me a distance, which is not a vector, so you would just tell me 6, right? So you can totally do this problem if you were moving like Pac-Man, in only up and down and only right and left. But the problem is we're moving like the video games that they have now, at angles, distances with angles. Does that make sense? So here's what we do. Let's call this L1. We cool? And we'll call this L2. Are we cool with that?
Yeah.
Oh, by the way, I'm probably going to write down L1 equals 400, L2 equals 300. I'm going to call this theta. Theta equals 30. And I'm going to call this one phi. Phi equals 50. Another Greek letter. Are you freaking out about that?
No.
It's just a different Greek letter. I didn't want to use theta again. Maybe here. How's about this? I'll call this one theta 1 and this one theta 2. Because that's L2 and this is L1, so maybe that might make sense. Does that make sense to you now?
Yeah.
All right, good.
Or it's like easier.
So what I'm going to do now is I'm going to look at two separate triangles. I'm going to look at this triangle right here. Here's the first triangle. You see that triangle?
Yeah.
All right. I'm going to call this L1X. We'll call this L1Y.
Wait, is there gonna be 3 triangles?
There are 3 triangles, yeah.
Oh, okay.
Do you understand what the L1X is? Maston says no. I don't know what he says no to.
That it's like meters kind of thing, like how you explain it.
Here, let me erase this because I think it's confusing the heck out of you. Maston, give me a question. You can't just say no and expect me to know what you're talking about. And Alice, if you understand it, explain what is L1X.
Like the y-axis thing. I don't know if you heard that.
This is the length 1, and this is the X distance you would have to walk to get to X, to make L1. If you walk this amount of distance in the X direction and this amount of distance in the Y direction, then you'll get to L1. Does that make sense to you, Maston? I know you just showed up. Apparently it makes sense to Alice. All right, this is yeah, you're right. It is just geometry again. All right, so check us out. L1x is equal to what? I'm gonna just write it down. Does that freak you out? Oh, maybe I should put this. No, that's a lot better. Right, 430. Right. I put the ones down here because I'm talking about L1 here, right? So I can't just put L cosine theta. I put L1 cosine theta 1. We cool? Are you sure you're cool with this?
Yeah, like I figured it out when you put the ones. It was weird.
All right. Masson, do you get it? Because I'm skipping. You got here late. All right, Masson gets it. All right, then I'm going to move on. L1y is L1 sine theta 1. Which, plugging in numbers, that would be 400 sine of 50. Right? No. 400 sine of 30. Sorry. We cool? All right. Let's break our second leg of our journey into its x and y components. So our second leg of our journey looks like this. And I'm going to label this L2x and this one L2y. We cool? Do you understand why I'm choosing x and y? Because the L2x, that's the horizontal part, and the L2y, that's the vertical part.
Yeah.
All right, cool. All right, L2x is equal to, what do you think it's equal to?
300 and then
300 what?
300.
Perfect. It's L2 cosine theta 2, also known as 300 cosine 50. Yeah, perfect, absolutely. What do you think L2y is? Masson says sine, and absolutely right. You just do the same thing, but it's just with the sine. L2 sine of theta 2. Look cool? So, what I've done here is I've taken two vectors that have distances and direction, and I broke them up into their x and y components. All right? Masson, I gave this example right before you came that says if Pac-Man wanted to meet up with Mrs. Pac-Man over here, instead of traveling this distance at this angle, he could travel this distance, then turn and go this distance, and he would achieve the same result. Does that make sense? So essentially, instead of doing a two-dimensional motion, I've broken it up into two separate one-dimensional motions. Do you understand? Essentially, I could tell Pac-Man, or I could tell her drone, that if you want to get to here and end here, what you can do is you go this distance, and then this distance, and this, and this. Does that make sense? Do you see how breaking these two-dimensional things up into one dimension is advantageous? But wouldn't it be faster for Pac-Man to follow the hypotenuse? Yes, Maston, you're right. Wouldn't it be faster if Pac-Man just went from here to there? You're absolutely right. But here's the thing about Pac-Man. You've got 4 options with Pac-Man. You got right, left, up, down. Sorry, my friend. In the Pac-Man games I've played, I can't go diagonal. Does that make sense? So what we're doing is we're pretending that we're Pac-Man. We're saying, I know we live in a two-dimensional world. We actually even live in a three-dimensional world. But I know a two-dimensional world is more accurate. But I'm still stuck in this one-dimensional thing. I'm good with that. I've got those 4 equations. I'm good. So what we do is we say we take these 2 dimensions and we break them up into their one-dimensional components so that way we can solve them. Am I speaking crazy here, or does this make sense? Good. All right. If what I usually do, and what I feel like a lot of teachers do, a lot of physics teachers do, to much of the students' peril, is we skip over all of this stuff. We just say, hey, remember trigonometry way back when you learned geometry, SOHCAHTOA? We're going to apply that. And then they just go straight into two-dimensional motion. I find that's where all these physics students hate physics. So I'm spending this time to try to catch you guys up to speed. And I know that you guys know this. You know this stuff, right? Yeah.
Oh, yeah.
But you just haven't applied it yet. All right, here. By the way, let's figure out some numbers. I'll tell you what. Kaylin, what is L1x? Alice, what is L1y? And Maston, what is L2x? And I'll figure out what L2y is. All right? So Kaylin, what is L1x? Maston, no, wait, it was Maston. What is L1y? Alice, what is L2x? And I'll figure out what L2y is. All right, mine's is 229 or 230. Okay, mine's is 230. Yours is what?
Mine's -395.
Then you got it wrong. Because you're probably using radians and not degrees. I'm telling you, this radians to degrees thing, and here's the reason why I'm asking you to calculate so many things, and the reason why I'm allowing you to fail.
Oh, is it 200? Does that sound better?
200 sounds better.
Okay.
I mean, obviously, if the hypotenuse of this thing is 300, then this has to be some number smaller than. Does that make sense?
Yeah.
All right. Kaylin, yours is wrong. Totally. 61? Are you kidding me? Can't be 61.
That's too small.
If this is 400,
That's too small.
how are you going to tell Pac-Man to walk 61 miles this way and expect to get there? No, it's not 400. It's not 61. All right. You got what?
200.
Just straight up 200?
Yeah. No, wait, I thought I was doing L1.
Oh, you're doing L1X?
No, L1Y.
L1Y?
Yeah.
Okay.
It's 200.
That sounds like it could be right. No. You don't do the sine of 300. Theta 1 is 30. Alice, can you do L2x for me as well?
Okay. 192.
Oh. I'm sorry. I forgot who I assigned to what. But let's see. What did you get for L2x?
192.
192? Try to do L2y, because Maston is saying 300, I'm saying 230. I think I'm right. I can actually tell you that Maston's wrong right now. Oh yeah, you're right. L2 is 300. No. I see what you're saying. I thought you were saying L2 Y is 300, and that's not true.
It's 229.
229.8.
Yeah.
Which is 230. All right. All right. Do L1x. I guess Alice, you're doing the whole problem. But Kaylin, make sure you can figure out how to switch your phone to degrees. All right.
46.
246.
346.
346. That sounds more like it. All right. So apparently, in the y direction. Let's talk about the y direction. Here's our final trip. This is where Alice started, and this is where the x is. In the y direction, how far in the y direction does she need to travel? Does her drone need to travel? $430. How did I get that? 200 plus 230 is 430.
Oh,
Does that make sense?
yeah.
Does that make sense online? In the x direction, how far does her drone have to travel? Use your calculators. I think I should make a new precedent. Bring your calculators to class, folks.
530.
No,
Oh, yeah.
you added them, did you?
Yeah.
Why would you not add them?
That one's on top, so then it's like
No, this 192?
it's like on top of like 346, right?
346 minus 192.
That's why.
How come?
Because it's like on top of it. And
What do you mean on top of it?
Like it's like above it. So I don't know.
What you mean maybe is this is 346 east and this is 192 west, or 346 to the left and 192 to the right. Does that make sense?
That's a better way of explaining what I was trying to
Is that what you mean by on top of it?
I was thinking of more like there's like leftover room. You have to find leftover space.
Yeah. Basically, this length that we're trying to find has an x component of this. So it's 346 minus 192.
It's 140,
154?
Yeah.
All right, 154. Are we cool? So, how do you find the distance that your drone has to travel now? This is a really good problem, by the way. Because when we get to the chapter on forces, you're gonna have to do this not quickly, but you're gonna have to do this a lot. How do you find the distance that they have to travel? Because this is the x component of the distance you have to travel, and this is the y component of the distance you have to travel. But what is the total distance that you have to travel? You guys want to know the formula? I'll tell you what it is. It's 154 squared plus 430 squared, and take the whole square root of that. And that's your answer. That's how far you have to go. Somebody asked me where I got it from. Where did you get that from? Or tell me where I got it from if you know where I got it
I don't know where you
from. Huh? You do know where I got it from?
No, I don't know at all.
So ask me, where did you get it from?
How did you get it? Wait, doesn't it cancel out?
Okay, I'll tell you where I got this answer from. I'll tell you. You ready? This is the x component. This is the y component. Kaylin figured it out. That's the distance I'm trying to look for. I can use the Pythagorean theorem. A squared plus b squared equals c squared.
Oh.
Does that make sense? Ah, pretty good. Pretty good. Okay. So, how's your brains with this one? Is this one all right?
Yeah.
All right. I got another question. Here's part B. And what direction? Because, I don't know. Tell me what the answer is. What is the square root of 154 squared plus 430 squared? 456? All right. That's our answer. So, could we go over the first problem and say something? Yeah, all right, fine. We'll go over some homework. After I finish talking about this problem, we'll go over homework. How's that? So, Alice, what you're telling me is that you're going to tell your robot to get to the X, and the robot is going to ask, okay, how do I get there? And you say, well, go 456 miles. Will your robot get to the X? No, will it? Will it? Nope. If you were a helicopter pilot and I said, get to the location, and you asked me, well, how do I get to the location? I told you, go 456 miles.
Oh.
What would you say? You say, okay.
I need another direction.
There we go. There we go. Which way? 456 miles south? Right? If I'm traveling 456 miles, I better know a direction. Or else I wasted a lot of gas or walked them really far away for nothing. So I guess the next question, part B of that, because all I have is a distance right now. What I want to know is what's the displacement? And for the displacement, we want an even more accurate answer of just the distance. We want a direction as well. So for part B of this question, I would ask, what is the direction? And I'll show you how to find the direction. It's actually quite easy. The direction over here is theta. Got it? If I knew theta, if I knew the angle, then I could tell you, you would travel 75 degrees north of east. Good. If you were a helicopter pilot and I told you to go 456 miles at 75 degrees north of east, you would know exactly where to go. Right? I don't think the answer is 75, but I'm just saying. So how do I find theta? This is part B of the problem. Do you know? Which side is this? Is this the hypotenuse, opposite, or adjacent? This is the adjacent side. Which side is this?
Opposite.
Is there a trig function that deals with opposite and adjacent? Ah, the tangent of theta is equal to opposite over adjacent. So apparently the tangent of my theta in question is equal to 430 divided by 154. Theta is equal to the tangent inverse of 430 divided by 154. Does anyone have a calculator? And can you do that? Do you know how to type in inverse tangent?
No.
It's a button on your calculator.
I only like the 5.
I think Wolfram Alpha will do it. Type in Wolfram Alpha. Go to Wolfram Alpha. It's a really good calculator.
So how do I do that?
All right, in the Wolfram Alpha search bar, type in TAN caret -1. Okay,
Caret -1.
All right, open parentheses, 430 divided by 154. Close parentheses. What are you talking about on the CDs? I don't understand what you're talking about. Oh, your Chromebooks? Yeah, your Chromebooks can do this. Yeah, totally.
Am I looking for the decimal?
All right, let me see what Wolfram Alpha gave her. Perfect. 77. All right. The answer that Wolfram Alpha gave her was 70.3. Is this kind of calculator on your Chromebook? It sure as heck should be. I'm pretty sure. I'd be surprised if your calculator can't do sine, cosine, and tangent on your Chromebook. So you tell your drone go 456 miles at 70.3 degrees north of west or north of east, and your drone will get exactly to the X. Does that make sense? You understand this problem? I spent a lot of time on this because it's important. Breaking two-dimensional vectors into two one-dimensional two one-dimensional components is probably the hardest thing that physics students have that they deal with, and they don't like it at all. And I keep on telling you that physics is getting hard, and I've actually got a response back that says, no, physics hasn't been bad yet. And my answer to that is, okay, you've got an awesome teacher. There's that. But I want you to understand this thing really well. You understand this thing really well, I promise you the next 4 or 5 weeks is going to be nice for you. If you struggle with this, the next 4 or 5 weeks is going to be hell. We cool? All right. Kaylin, which problem you want me to take a look at? Today's homework. All right, let's take a look at it. Column 1. Wait, Alice, you also wanted me to work on some stuff, right?
Yeah.
What do you want me to look at?
We can check today's first.
Okay.
I want to see some of the other homework. I think 2 days ago. 2 days.
All right. Question number 1. Legend has it that Isaac Newton was hit on the head by a falling apple, thus triggering his loss by gravity. Assuming this story is true, estimate the speed of the apple when it struck Newton. Oh, okay. I think that this problem is all about giving me reasonable information. Oh, you only got 1 shot on yesterday's homework? Oh, I'll give you 10 shots again. Yeah, I'm sorry. Let me go fix that right after I'm done talking about this problem. All right. I can erase this, right?
Yeah.
Okay.
I don't need
With the problem that Kaylin's asking, I believe, is if I have an apple that's hanging out in a tree, and here's Isaac Newton. He got smart when an apple hit his head. That's not true, but that's the way the legend goes. What was it? What was the speed at which the apple hit his head? Yeah, what was the speed? All right, cool. So you got H, you got V naught, you got gravity. You got T and you got V final. Huh?
That's a lot.
Well, no, these are all the 5 things that you could have,
Oh,
right? These are the 5 variables that we always have. Okay. Now, do you guys know what V naught is?
0.
It's 0. Good. Because the apple tree didn't throw the apple at Isaac Newton. The apple tree just kind of released the apple, right?
Yeah.
We're not talking about Wizard of Oz apple trees. No. Okay. All right. And then, you know what gravity is?
Negative 9.81.
Yeah. I'm just going to make it negative 10.
Okay.
Actually, I'm just going to put 10. I'm going to put positive 10, even though it's... But I'm going to put it right next to a squiggly arrow going down.
Okay.
So it kind of makes you think, oh, that's negative 10. Does that make sense?
Yeah.
The V final, that's something of interest, right? That's what we want to find. What about your H? We weren't given the H.
So it's like nothing.
We also weren't given the time. Here's the problem. This thing is saying, what is the... How did I phrase the question?
Yeah, it's
Get an estimate. So which one do you think you can get an estimate for? The height of a tree or the time it takes for an apple to fall from a tree? Let's go with the height of a tree. Yeah? In fact, let's say it's 12 feet. Cool? That's about a reasonable apple tree. To be honest with you, I've lived in Hawaii all my life, and I have no idea what an apple tree looks like. But I'm just saying, 12 feet sounds about right, right?
Yeah.
And we're not talking about, like, apples falling from palm trees here. Right? Are they average 12 feet, Maston? Or are you talking about, like, 50-foot trees? Because if a coconut fell on Isaac Newton, he'd just be dead. See, Maston's from the mainland, so he knows. I'm a dumb Hawaiian island boy. That was racist. I'm sorry.
And you're not even Hawaiian, so you can't say that.
All right, I'm not Hawaiian. I can't say that. I grew up here. I can consider myself Hawaiian. I'm married to a Hawaiian. I play ukulele. I sometimes surf. All right, about 20. Let's go with 20. Here's something that you're going to have to do, though. We're going to have to change this number from 10. Do you guys know what gravity is in feet per second squared is? Because this is 10 meters per second squared, or 9.81 meters per second squared. If you don't know it, then you won't know it. It's just straight up 32. 32 feet per second squared. That's how you have to change that. Wait. Maston is saying average apples grow at 20 meters in the tree. I can say that with confidence. 20 meters is tall, dude. That's 20 of these things.
I don't think they're that tall.
Are you saying there's like a 50-foot tree out there? Apples don't grow into 50-foot. How do they pick them?
You gotta get a really tall ladder.
They don't get 50-foot tall ladders. No. Fine, look up an estimate of a tree for me, please.
Apple tree.
Yeah. What would you say?
Like in California?
It doesn't really matter. An apple tree is an apple
It's
tree.
like 30 feet, 25, 30 feet.
30
They're
feet?
pretty big- They can be pretty big trees.
But not 20 meters.
No, I don't think so.
That's
I don't know.
Right. All right, 30 feet. Okay, all right, 25 to 30 feet. Good, fine.
Did you Google it? Did you Google it?
Let's say 30 feet. Fine, good.
Yeah, it's about 30.
Then, do we have all the information we need? Oh, by the way, do we need the time? No, that's our DKDC. Which equation would you use, by the way? Delta x equals v naught t plus 1/2 at squared. And you notice how whenever I change this from a delta x to a delta y, you notice that?
Sometimes.
Because
I pay attention to it.
I sometimes notice because I don't really pay attention to you. It's not a delta x, it's a delta y, and the reason for a delta y is because we're going in the vertical direction, so we're talking about the delta y. Does that make sense? And I'm going to do this now that I talked to you guys about vectors. I'm going to do this. Because we're talking about the y direction, so we want to talk about the velocity in the y direction, and we want to talk about the acceleration in the y direction. The reason why I'm going to do this is because these little subscripts don't have any part in this problem right now, but they will when we cover two-dimensional motion. Because I'll tell you what we're going to do. We're going to take this two-dimensional motion problem and break it up into two separate one-dimensional motion problems. Just letting you know for the future. Anyway. Oh, wait. I don't want to use this equation. Absolutely not. Not this equation.
That's T.
It has t. And if t is my don't know, don't care, I don't want to use an equation that has t in it. I think the other one is v final squared equals v initial squared plus 2a delta x.
Okay. That seems, yeah.
Were you going to say something?
No, that seems like.
No, were you going to say, hey, wait a second, that doesn't make sense. Why are you using that
No,
equation?
I wasn't say that. I was gonna say it's right.
No, I was actually hoping you would have said that.
Oh.
Like, I was like, you were looking at me funny. You're like, why are you using that equation if it has t? And your t is, I don't know it, nor do I care. All right. We forgot to do a coordinate system for this thing. We need to do an xy coordinate. Technically, we only need a y coordinate because we're only moving in one dimension, but I'll do an xy coordinate. You want to call it positive and positive?
Okay.
Because I don't.
Like positive, negative.
I want to call it positive and positive like this. I want to call it down positive. I explained this in great detail in my archive. I think it was last week Wednesday. You should go and watch that one.
Okay.
I'm not going to get into it now because... Oh, it was on Monday. Oh, okay. So there were two things on Monday that I posted yesterday, or I posted recently, that maybe you should go back and watch.
On Monday?
Yeah.
Okay.
Yeah, so watch Monday's archive if you don't understand why I'm calling down positive. All right. So V final is what I'm looking for. V naught is 0. 2G delta Y. So I would say it's equal to V final is the square root of 2 times 32 times times 30. What is 2 times 32 times 30 and then square root that? I think I made a mistake here by converting it to feet, by the way. Well, we can fix that. You got the answer? Square root of 2 times 32 times 30?
1,357.
No, you didn't take the square root, did you?
Oh, I don't know.
You did 2 times 32 times 30?
Yeah.
Yeah, you need the square root of that.
Oh, 53.8.
That sounds right. 53.8.
Right, 43.
43.8?
43.
Sounds even better. And that's feet per second. Right?
Yeah.
Okay. The reason why I told you I might have made a mistake in converting it to feet, changing this to a 32 and changing that to 30 feet, is because I'm sure that when I asked for the answer, I asked for it in meters per second. So I got to convert this 43.8 to meters per second. But here's the thing. The reason why I converted it to feet is because me being a dumb American, I don't know how to measure things in meters. Like, I don't know off the top of my head, oh, that's that many meters tall. So, you know, can you convert 43.8 feet per second into meters per second for me? Really, just what is 43.8 feet in meters? 13 point what? 3 meters per second. So the answer is 13.3 meters per second. And I think that when Maston said, his mom says that her tree is 17 meters. Okay. Okay. All right. I'll tell you why you got that problem wrong is because I screwed it up. The answer that I wrote down is 7.7. But I gave you a margin of error of 10 meters.
So 13 would be correct.
So 13 is within within 10 of 7.7.
Oh, okay.
You could have put 17.7 and still have the right answer. You could have put 0. But what you can't put is 30 meters per second. That would kill Isaac Newton. And that would fall from probably a 20-meter tree that Maston is claiming. I'm smiling. It's sarcasm. Maston is saying 17. All right, fine. Plug 17 in for this number right here. But instead of using 32, put 9.8, because then we'll just be doing. Maston is saying his tree is 17 meters tall. Really? That means you need like a 40-foot ladder.
What I found was that they do get really tall, but they stunt their growth.
Oh.
Farmers can stunt their growth.
Yeah, they selectively breed them?
Well, they can do that, or they can just trim it,
Yeah,
keep it shorter.
so that way you don't need to kill yourself. Right. And I'm sure that if you have a full-grown apple tree that's 17 meters tall, I wouldn't stand under it. I don't hang out underneath the mango trees in Hawaii. I go and get the mangoes, but I don't go and hang out there. I don't put my porch over there and like set up beach chairs over there. That mango hits you. I don't hang out under coconut. Well, I do. It's rare that coconuts fall. I've seen it though. Those things crash. All right. Anyway, Kaylin, I think that the reason why you had trouble with this problem is not necessarily because it's hard, but maybe because you're not used to estimate. You're used to me giving you every single number. And what I wanted you to do is give me a reasonable number. I think that when I did this calculation, I was assuming that this tree was not 30 feet tall. I was assuming that this tree was maybe 10 feet or 15 feet tall. And that's why I got an answer of 7.7. But you guys are assuming that this 30-foot tall this 30-foot tree, the apple that fell on Isaac Newton's head was from the very top of the apple tree, which is a fair assumption. Still within our range of reasonable answers. One does not simply sit under a 10-foot tall tree. Well, maybe on the mainland, but in Hawaii, we're only 5'9". Was that racist?
Just made a mistake. Most of the demographic is really short.
We're way shorter than people on the mainland.
Not all people, I
No, that's true. I probably shouldn't upload this archive.
Says the Filipino.
Right. I'm admitting that I'm only 5'5",
You're 5'5"?
5'6" on a good day.
On a confident day. When I wear my sneakers.
I never paid attention to that.
Why?
That you're shorter than me. You never
Oh.
even thought of it.
You know why? It's because I scare you. So you just think that I'm taller than you.
It's totally.
I intimidate you, don't I?
Chemistry and physics is just very much what it is.
No, you killed chemistry, man. You were really good at it.
Science is much it.
I even tried tripping you up sometimes.
Oh.
Yeah, no, I have to applaud your mad chemistry skills.
Thank you.
You want something also challenging is physics. You should try it.
I'm taking that next year, so it'll happen.
Oh, cool. Well, I gave you away the big secret. To do two-dimensional motion, all we do is break it up into two one-dimensional motion problems. So once you master that
Wait, so
two-dimensional,
It's like if the motion is this,
Mhm.
then you break it up. Or if the motion is this, then you break it up into this and this.
Exactly,
So you break it up into it going up and it going over
exactly.
instead of it going up and over.
Yep. It's almost like if actual two-dimensional motion is described by parabolas. It's almost as if and this isn't necessarily true. Maybe I shouldn't make this analogy. Never mind. It's almost as if like if I were to, I have a video that I posted where I threw a basketball into the hoop. And I posted that video because I've only done it a couple times. But you have, this is what a picture of a basketball going into hoop looks like, right?
Yeah.
And you've got the person here and the hoop way up here. Pretty cool? And this is described by a parabola.
Yeah.
But we don't look, when we solve the problem, we don't look at this motion in two dimensions at the same time. It's confusing to us. So what we do in physics is we said, all right, imagine you're a bird 1,000 feet into the air, way up here. That looks more like a plane. Fine, you're a plane 1,000 feet up in the air, and you're looking down at this basketball. Yeah, you gotta leave?
Yeah, because that worked.
Alright, yeah.
But I remember the plane bird part because you told Alice about that last week.
Oh yeah, all right, fine.
But no, the question I had actually, because I got that when you were talking about just dividing into two different motions.
Yeah.
What if it's this, but it's also this?
What if it's spinning?
Yeah.
We won't get into that in high school physics.
You won't get into that?
No. I've taught that before.
Why won't you get into that?
I've taught that at Leeward Community College for Civil Engineering 271.
Oh shit, really? That's gonna be a ways away for me to find out.
Well, this motion is hard enough for high school physics to do. When you add a spinning component, that's where you get into some pretty advanced stuff.
I mean, like, even just a football has that motion.
Yeah. and I could explain it to you. I think that it would take me about 3-4 boards and your brain would fall off from the math. I know that you're good at chemistry and you're good at math too. But it's not something I don't know how to do. I can totally do it. It's just, I don't necessarily know if I could teach you in high school how to do it.
What?
Or maybe I could as a specialized thing, but I don't teach it in general to like everyone in high school.
What does
It requires, it talks about torque and rotations.
Oh.
And then you have a basically what you're talking about is you're saying, there's a Wilson symbol on my football, and I'm a bug that is standing on the W, and Peyton Manning throws the football at a certain angle or whatever, and so not only am I going in an arc, but I'm spinning around like that. So what you're talking about is what you would do is you would take some axis, some three-dimensional axis. You would rotate that axis. It would spin. And then you would take the origin of that axis and put it on that parabola. Do you understand how this is starting to get complicated?
Yeah, I'm like imagining just like
Yeah, you know
just
how.
grasping the concept of like because you think about it sports wise and you think about just throwing a football, right?
Yeah.
And it's pretty easy. Like,
You know how you have an XYZ coordinate system right here?
Yeah.
Here's an XYZ coordinate system. All right? Now say that this is the football. There's a giant football around this thing. And I'm a bug that's sitting right about here.
Yeah.
Well, what you're going to do is you're going to take that entire axis and just rotate the whole axis. Like that. At some speed. We call omega. And then you take the center of that axis and you put it on the parabola.
that's a lot.
And that's how you solve the problem. So the math is going to get really dicey.
That's a lot like just trying to conceptualize. Because like
Yeah.
if you think about it just sports physically it's simple, but
Yes.
if you think about it
Yes,
mathematically, it's
But that kind of math is really important for the dudes who shoot satellites up in the air.
Yeah.
I'm just letting you know, like satellites go up and they spin and they follow all kinds of equations of motion and that kind of stuff. Super important. You want to do that kind of stuff, yeah?
Are you going to the rally?
No.
Are you changing your
I'll
rally shirt?
represent.
Represent. I wore my HSDA shirt yesterday. All right. Hey, I'm sorry I was so racist today. I don't know if I was. Was I?